Hi, I'm going to go over the answers to this worksheet called Classes, Objects AP Style Worksheet number 1. Let's begin. Number 1, the answer is definitely A because as we've studied it at least, main methods are always found in client programs, or also known as test classes. While a regular class such as bug or turtle could have a main method, generally they do not. They only have things like constructors, accessors, modifiers, interesting methods. So the best answer for number 1 is main. Number 2, here we have a theoretical class. I chose to type out the instance variables at the top of the class here. And one of these methods is one of these methods given in the choices for number 2, A, B, C, and D, is the best candidate for being a static method. A static method is a method that applies to all of the objects that are instantiated in a client program at a given time. So let's consider them one by one. Would a move method apply to all of the bugs in a program at one time? No, each bug should move individually in his or her own chosen desired direction. Move is very individual. Eat, again, eating is something that each bug does individually. When and how much he or she would want to eat. Get weight, an accessor method, again, applies to a specific bug. One bug might weigh 10 bug pounds, whereas another bug might weigh 200 bug pounds. However, get grid size, that's the answer because the grid size is something that's consistent or the same for all of the bugs. All of the bugs in a particular program are probably in the same grid, at least the way we study bugs and turtles and other objects like this. And if you ask bug A, hey, what's the grid size? He or she would say 10 rows and 10 columns. If you ask another bug in the same grid, hey, what's the grid size? He or she would say 10 rows and 10 columns. It's not a matter of debate. Just like all of us humans would agree that the Earth size is the same because we all live on the Earth. So the best answer for a method that's static in a class such as bug would be the method getGridSize. Number 3, the answer is C. This is really just a matter of definition and knowing your vocabulary. Let's rule out number A. Methods are usually public, not private, so that's just kind of wrong. B, that's ridiculous. You can certainly have a client program that has 2 or more objects. You could have a program that has 15 bugs or 15 string variables. So that is bogus there, that word 1. D, no, the interface of a class is its set of public methods, which are public and therefore exposed to client programmers or users. So the interface is actually never hidden. It's meant to be seen by the public, by client programmers that did not write the class itself, but wanted to use the class. And E, you don't begin the names of object variables with my. You begin the names of instance variables, also known as properties, within a class with the prefix my. But in a client program where you have maybe a bug named Nemo or a turtle object named Donatello, those names don't ever use the word my as a prefix. So the answer for number 3 is definitely C. Number 4, the answer is A. That's false. A default constructor never has parameters. If you had a class named bug, then the default constructor would be typed out as public bug empty parentheses. And then in your curly braces, of course, you would set things like my age equals 0, etc. So the default constructor, just by definition, what makes it the default constructor is the fact that it has no parameters in these parentheses right here. B is true. Constructors never return a value, so that's wrong. That's false, or that's true. I mean, so it's not the answer. C, that is true. You can only ever have one default constructor at most in a class. And D, that is true. You can have more than one constructors that do have different parameter lists in these parentheses. You can have two or more, one or more. So that's wrong. So that's a true fact, and therefore not the answer number 4. Moving on. Number 5. This is, again, a definition. Just look at my lecture notes. Another name for a property is instance field. These up here are examples of instance fields. Not to be confused with an instance variable, by the way, or an object variable, which is the name for something like Nemo or Flick or Donatello that you would find in a client program. So instance field are the names for also known as properties. 6, the answer is B. An object stores its state. You should know that state of an object has to do with its properties, which are also known as instance fields. On the other hand, an object's behavior has to do with its methods, its public methods, or rather its interface. So this is just straight vocabulary. Study the lecture notes, read them over and over again until you absorb these facts to be prepared for the AP exam, please. Number 7, the answer is A. This is tricky. Let's check out the answer. The answer is the answer because Roman numerals 1 and 2 do have the same method signature. The method signature of a method is its name along with its parameter list. Now, sometimes I just consider the parameter list to be the signature, but I think formally it's also the name of the method. Check this out. These two proposed answers here, do something string A int B and do something string name int num, they are the same. The parameter names don't really matter at all. Parameter names, formal parameters that is, in the header of a method, don't really matter. Some word plugs in for A, some number plugs in for B. The fact that we have the same name, do something, and the same parameter list, string, comma, int, and string, comma, int, means that Roman numerals 1 and 2 do have the same method signature. They would not be allowed to be used in the same class. They are not examples of correct examples of overloaded methods, in other words. Now do notice that they have a different return type, double and int, but officially return type is not part of a method signature. If you read the lecture notes, you would know that. So reread them if you got this one wrong. That's just the way it is. If you look at Roman numerals 2 and 3, for example, they have a different parameter list. Here we have a string, comma, int, and down in Roman numeral 3 we have an int, comma, string. Because of the different order, that means that their method signatures are different, and therefore they are not the 2 and 3 are not the answer here. So B is not correct. You could use Roman numerals 2 and 3 as overloaded methods in the same class if you really, really wanted to. Moving on, number 8. We have a car class, and let's see what there is to do. Well, we have 3 properties here, and I have to move to the next page to see what the rest of the question is. Okay, what's true about all this? Well, it's D. The answer is D. By default, if you have no constructor in a class, even though properties should be initialized in constructors that are available and typed out in that class, if not, ints will be initialized to 0, and a double property will be initialized to 0 or 0.0, same thing, by default. And in this case, because of this example, all 3 of these properties here are doubles. There are no strings or objects, like there's no color object with a capital C, or bug with a capital B, or string with a capital S. So the answer that I saw here and answer D is not, C rather, is not correct, because even though null acts like a zero in a way, it is only used when you have objects that need to be initialized, because this is really the memory address 0 and not the integer value 0. So C is officially wrong. And apparently A and B are wrong also. I don't have time to go over that right now in this video. Number 9, the answer is B. That's related to the question number 7, Roman numerals 1 and 2. Both had the same name and the same signatures, so they were not allowed to be used in a program, and therefore a squiggly underlying compile error would occur. In other words, they are not examples of overloading correctly. So this is not, so the answer here is just B. Aliasing is something totally different. That has to do with object variables in a client program and not two methods in a regular class. Number 10, the answer is D. Apparently this is not true. Got to pay attention to the wording here in these AP style questions. They like to trick you. Each object variable stores its own memory address. Usually it does, but not always. Consider this. Let's say in a program you have bug Nemo equals a new bug. I don't have room to write this, but pretend that I wrote new bug out here to the right. And then you have a line of code that says bug flick equals Nemo. Well, we previously studied that when you set an object variable equal to another object variable, they both store the same memory address. It's an example of what's called aliasing. So Nemo might be the memory address A32, but because flick equals Nemo, that A32 gets plugged into flick, so it's a different object variable, I agree, but it doesn't have its own memory address. It doesn't have its own location in the memory of the computer. It's really just like a shortcut to a program on your computer's desktop. It's not another copy of the program itself. It's just another way of referring to that same underlying object where the age and the weight and other properties are stored with values. Flick has an age of 0, but so does Nemo. In fact, they're really the same object. They both point to the same object. So let's see here. The answer then to that question, number 10, is D, because D is worded incorrectly. That is not always true. They're not always unique. Sometimes they're aliased. Number 11, this is very tricky. Here we have a small class, and we have to trace this code that's coming out of a client program, some public static void main string args somewhere. Okay, let's trace it. B1. B1 is an object variable, and it's a new bank account, 500. Let's see what this 500 does. The 500 plugs in here for initial balance because we're calling the constructor that takes one integer parameter, and that would be this constructor right here. Oh, by the way, there is no default constructor. I just happened to notice. Anyway, the 500 plugs in for the formal parameter initial balance. It goes from right to left here, and it plugs into my balance. And by the way, when we declared B1 as a bank account, it was given a memory address by the operating system. So somewhere in the memory of the computer, there's this memory address A32, and at that location, there is a property called myBalance. It's a double. I'm just going to use myB because I don't have room. And in this because of this line of code here, 500 is stored there. Okay, let's execute the next line of code. B2, that's nice. B2 is a bank account. It's being brought to life with a memory address. But wait, because these parentheses are empty, we must call the default constructor that in the bank account class. Well, there is no default constructor. This is the method deposit. This is the method getBalance. This is the property declaration. This, as we've already discussed, is the constructor that needs a double parameter in the parentheses, like the 500 was. So there is no default constructor, and so your compiler, such as Eclipse, would have squiggly underlined this and told you, the programmer, that this is just bad code. You can't do that. So the answer is E, an error occurs. Very tricky. Number 12. Okay, well, let's forget all that nonsense and pretended that we just executed this code in a client program. So let's trace it. B3 is the bank account object. It is properly calling that constructor up above. So we have somewhere in the memory of the computer, maybe the memory address A32, where the balance is 500. So this object variable points to this object itself in the memory of the computer. Just like when you double-click an icon on your computer's desktop, the program Internet Explorer or Firefox or Safari opens up. But you would not say that the icon is the program. The icon is really just a way for the computer to store a memory address. Okay, the next line of code. We have aliasing. This is a great example of aliasing. B4. B4 is an object variable, but it's equal to whatever B3 is. Well, instead of copying this whole chunk of memory into B4, which is illegal, by the way, we're actually just copying A32. A32 is being stored into B4. Some memory address, some hexadecimal memory address we could think of it as, is being stored in B4. Okay, so that's what the second line of code does. Check, check. Okay, this line of code, B3.deposit. 100 is plugging in for the parameter amount, and that number 100 is therefore being added with my balance. Well, my balance is whatever the balance of B3 is, because that's who is calling the method deposit. B3 is really A32, which sends us here to see that my balance is really 500. Okay, so 500 is the number that you should plug in here in your scratch work. And 500 plus 100 is 600, and that 600 plugs into the variable new balance. What the heck? New balance is really just a local variable that was locally declared in the body of this method, and it's equal to 600. And then this line of code takes that 600 and it assigns it into my balance. Well, you got to stay focused here. My balance is currently the balance of B3, because we just called deposit with B3. So that 600 gets plugged into B3's balance. B3, A32, we're putting the 600 in here. So now the question is, what are the balances of B3 and B4? Well, without even looking at my choices, I can see that the balance of B3 is obviously 600. But B4, which is really just a pointer or a reference, we say, to the same object in the underlying memory of the computer, so B4's balance is also 600. B4 is really just a nickname for B3. They're really the same guy. It's just like calling your checking account fund money. Let's say you have a checking account that the bank calls it your checking account, but you just call it fund money because it's a checking account where you just put your like bonus money that you get from your job and you do fun things on vacation with it. So when you say, I'm taking money out of my account called fund money, it's the same thing as taking money out of your checking account. You just have a different name for it, that's all. That's an example of aliasing. So the answer should be 600 and 600. Let's go to the next page to see if that's one of the available answers. Yep, you bet, it's D. And that's why the answer to number 12 is D. Moving on to number 13, let's trace that code. B3. B3, let's just pretend, again, it stores this made-up memory address A32, which is where in the computer there's room for a bank account object that has a balance of, again, what a coincidence, 500 is being used. And now we have aliasing, so B4, again, is just a A32. So that's that. Now, B3 equals null. Null is a built-in Java keyword that means memory address 0. This is not the same thing as typing b3 equals 0. So you got to type the word null. And what that's doing is it's putting the memory address 0 into b3. That is not the number 0, it's the memory address 0. So that's that. Now we get tricky here. Working from inside the parentheses out. b3.getBalance. Well, let's go check that out. What is b3's balance right now? Well, b3 is memory address 0. So there's no longer a link from b3 to this object. That's been destroyed. The computers erased that. So this is illegal. You can't even get the balance of an object that's at memory address 0. It's illegal because there is no object stored at memory address 0 now, and it's just illegal. So that's an error, and the answer is E. Number 14. B5 is, I'm tired of A32. Let's just pretend it's memory address B52 for fun. And at the memory address B52, we have a balance of 200. Because of this 200 that went to the other constructor, we've already been over that. Here we have aliasing. B6 is equal to B5, which really just means that B52 is stored in B6. I'm pausing right now. Okay, so resuming from our station break here, number 14, I'm partway through it. B6 is aliased to B5, so they're both storing the memory address B52, as you see here. Now check this third line of code out. B5 equals null. Hey, just like we saw in the previous problem, I got to cross this out and make it a 0. That's memory address 0. And then B6 deposit 100. Well, that's pretty straightforward. You send 100 to that deposit method on the previous page. And so in this indirect way, it adds 100 to whatever B6 is. Well, B6 is balance. Well, B6 is B52, which points to this object, and the my balance is currently 200, so we're adding 100 to that 200. Trace the code on the previous page to see how it actually adds in there, but just trust me that there's now a 100 here. So the answer, of course, to this question is, I'm sorry, I didn't add correctly. 100 plus 200 is 300. So the answer is C. And this shows that when you set one object variable equal to null, it does not mess with other object variables that were aliased to that same object. It only applies to the object variable into which you're assigning null. B6 is unaffected by this third line of code here, B5 equals null. Okay, moving on. Like they do on the AP exam, they love to throw these classes at you, and you have to interpret and trace these classes. So also notice that to save space on the paper, the AP people and myself, they like to just show methods sometimes as a set of empty curly braces, and you're supposed to just trust that the implementation, that is the code that's in the body, just works. So just assume that this default constructor here for the time class just works. And just assume that this other constructor that takes 3 parameters, just assume that it works, etc. Okay, do notice that we have 3 properties. They're all ints, and that's that. So moving on to the next page where the actual question is for number, whatever we're doing here, 15. Which of the following is false? Well, there are no static methods. Let's investigate that possible answer. Are there no static methods? Well, a method would be static if it has the keyword static in its header. And I don't see the keyword static here anywhere, so A is not the answer. A is not false. It's actually true. B is worded, reset time is not a constructor. Well, you don't even have to look at the class to know that answer. Constructors always have to have the same name as the name of the class. So the time class has constructors named time. So B is not false. C, time is a default constructor. Again, you don't even need to see the class to know that that is true and therefore not the answer. Because a default constructor always has empty parentheses. The name of the class is time, so that is the only allowable name for a default constructor. So that is a true statement. So these are all true. And moving on to D. Well, D is true also, because H, we see over here on the previous page, is being used as a formal parameter right here. So is M, and so is S. And so is T, by the way. So H is used in this class as a formal parameter name, and therefore D is a true statement. So the answer must be E, and yes, all statements above are true, and that's that. Number 16. Which of these would be plugged in for the constructor that has parameters? Now that's another way of saying other constructor. That's what I call other constructors. They're just simply constructors that do have one or more parameters. So if we go and look over at the class, what needs to be done in that other constructor? They have a little comment here. Oh, no, they don't. They just say implementation not shown. But right here is the, right here specifically is what we are supposed to answer. In other words, we're supposed to pick what code should plug into this set of curly braces. Well, we see we have the formal parameter names H, M, and S. And we want whatever number, like say 1, that's plugged in from a client program for H, we want that 1 to ultimately be plugged in to my hours. And let's say that the person for M is, I don't know, the number 13. So we want that 13 to be plugged in for the corresponding number of minutes, which is known as my mins. And let's just say 52 is the number of seconds. So that should be plugged in for my seconds. So the answer to this question is, well, this would not do it, because this doesn't even use the parameters H, M, and S. This just plugs zeros in. This is the code that should go in that default constructor, so that's not the answer. This is the right code, but it's kind of backwards. This is just, these assignment statements are not correct. And man, it's so close. B would be correct if it were just, these were written the other way around, but it's not, so that's wrong. Let's look at C. Now C, we're taking the parameters H, M, and S, and we're sending them to reset time. So if this code were typed out in this spot right here, it would actually work, because we're using the parameters H, M, and S, but we're then calling this available method named reset time. I'm sorry, it's reset time, not reset. And it's passing the H, M, and S from here down to here, to this H. So this M, because of this call statement, is being plugged in for this M. This S is being plugged in for this S. And this H is being plugged in for this H. And you're supposed to just assume that the implementation, which is not shown for reset time, that it does what they're telling you it does in this comment statement. Oh man, this is messy right now. So you're supposed to assume that this comment works and that these lines of code are being executed in the body of this method. And that's exactly what the other constructor would need to do. So the answer to this question is C. And I don't even have to read over the other two questions, which were bogus anyway, because that puts things to 0 and it doesn't set the properties equal to 0 themselves. And this is just illegal code. You do not want to instantiate a new object within the constructor of that object. This might look good, but you've never seen this done anywhere in any previous program. You cannot, in the body of this constructor here, you cannot instantiate another time object. It just won't. It won't do what you want because of the way memory addresses and everything works behind the scenes. It's just not correct. Okay, we have one more question to do, number 17. The answer is E. All three of these Roman numerals are correct. They're just different ways of doing the same thing. If you do look closely at the increment method on the previous page, the purpose of the increment method, as I read the comment here that's provided, the increment method is supposed to advance the time by 1 second. So there's no need for a parameter, and it doesn't have one. There are no parameters here. The number of seconds internally in this class is known, kept track of with the property named mySex. And to add 1 to mySeconds is just a matter of writing this line of code. That would be the easiest way to do it. Now this line of code works also, but you're just calling the getSex method and adding 1 to whatever value is returned by it, and then that new total is being plugged into mySeconds. So that gets the job done as long as there's an available method called getSex that does return the number of seconds. And is there? Yes, there is. There isn't that available method. It returns an int, and it says implementation not shown. And even though they didn't give you a comment, you should use logical sense and acknowledge the fact that that's an accessor method for the property called mySex. So it does get that value, and you are correctly adding 1 to it by the right-hand side here of this assignment statement. So that works. Roman numeral 2 does work. I would rather write the code Roman numeral 1. In fact, I'd rather write it as just mySex++. That's the best way to write it because it's shorter. But that would work, this would work, and Roman numeral 3. The word this is optional, and we normally don't type it out when we don't have to, like Roman numeral 1, but you can if you want to. If you're in the body of a class and you want to refer to a property within that class, you can type this dot. It works. Later in the school year, we'll see in a situation where this has a more reasonable use. For now, it just seems redundant, but it does work. So the answer is E.